Okay, so now you are experts in oceanography because you learned two big concepts: geostrophy, geostrophic balance, geostrophic currents, and western boundary intensification. Okay, you can take oceanography, or you might become a marine biologist, a geochemist, a observational person, a modeler, whatever. So you will add more knowledge based on what you want to become, or you'll keep this basic knowledge in your field of study, like physics, chemistry, biology, and so on. The mathematical concepts are much more interesting as well, but we won't do any of those. So we'll move now to the other part of the subtropical gyre, the eastern boundary currents. They are obviously on the eastern side of the ocean, but typically the western coast of the continent. For example, the west coast of Europe and Africa and have the eastern boundary currents. West coast of US has California current. West coast of South America has the Peru current or Humboldt current, and so on. Okay, so as opposed to the narrow, fast, deep western boundary currents can go down deeper than a kilometer. The eastern boundary currents, on the other hand, are cold. They are very broad and they are kind of slow, and they are shallow, just a few hundred meters as opposed to more than a kilometer. And they are wide. They are not. They are just responding to this mass balance to close the loop of the eastward, westward tropical currents, eastward subtropical currents, and the western boundary. Okay, so western boundary, Gulf Stream, Brazil current, Kuroshio, East Australian current, and narrow, usually less than 100-kilometer wide, carrying as much water as the broad subtropical gyre is bringing south. So they have to be very fast if they're carrying so much mass, and they tend to be deep, down to 2 kilometers, 1 to 2 kilometers. Not all of them are 2 kilometers, but nonetheless, they are fast, hundreds of kilometers per day. Hundreds of kilometers per day. That's more than a meter per second. Okay, as I said, most ocean currents are in centimeters per second, but the western boundary currents are in meters per day. Okay, they carry as much water as 100 Sverdrups. What is SV? SV is Sverdrup. Sverdrup. Below you can see in the footnote. Harold Sverdrup was one of the pioneering oceanographer who spent most of his time in California universities, Scripps Institute, and so on. And he discovered many things in oceanography, including some biological things. So this volume of 1 million cubic meters per second, or 35.3 million cubic feet per second of transport, is called 1 Sverdrup. How do you know how much that is? Well, you can think of rivers. So you think Amazon is such a biggest of the rivers in the world. How many Sverdrup does it carry? Just 0.2 Sverdrup. So essentially that means Gulf Stream will be carrying about 200 Amazons per second. Okay, so that's a lot of water. Waters are derived from low latitudes, so they are warm. There is little or no upwelling in them. Upwelling is not defined yet, but we will do that soon. But you remember when I said Kuroshio means black current in Japanese because it has no productivity, no fish, basically because it has no upwelling. We will see how upwelling relates to primary production, fish, and so on. Okay, eastern boundary currents are the Canary Current, Benguela Current, California Current, and the Lewin Current in the Indian Ocean. They are wide, up to 1,000 kilometers, as opposed to the 100 kilometers of the western boundary currents. They are fairly shallow, about a half a kilometer, as opposed to 1 to 2 kilometers of the western boundary currents. They are slow, only tens of kilometers per day, so about 10% of the western boundary currents, and they carry only about 10 to 15 Sverdrups this is not the interior subtropical gyre transport, okay? This is separate boundary current. So the western boundary current is carrying north, whatever the subtropical gyre is carrying, plus whatever the coastal currents are carrying, because the mass has to be balanced, okay? So waters are typically derived from mid-latitudes and are cool, and coastal upwelling is common along these currents, and we will see that. And it matters for the weather of the coasts that are near those currents. So the weather in the western boundary current coasts will be very different, warm, humid, rainy, as opposed to the eastern boundary currents typically tend to be cold, dry, a lot of fog, and so on. Okay, so ocean currents and climate, just to continue that concept, warm ocean currents warm the local air and they create moisture, and they obviously bring low pressure and humid climate. Cool ocean currents are cool, dry air, dry climate on the landmass. For example, California current produces dry deserts in California. A statement is attributed to Mark Twain often that says, "The coldest winter I ever experienced was a summer in California." California is famous for fog around the Golden Gate Bridge in the summer months, because the cold California current and the local upwelling produce cold waters. They create very cold air, and whatever little humidity is there ends up condensing and creating fog. Okay, so I will look at these ocean sea surface temperatures in the next podcast. So I will stop this here, and we will see how the sea surface temperatures change from place to place and from season